All right, so for our geometry here, there are going to be two types of triangles that we would just want to have kind of memorized and we just want to know kind of by heart. Those two types of triangles are going to be 45, 45, 90, and also 30, 60, 90 triangles. Now, what these are the angles that are within the triangle, and you notice that they are all including a 90 degrees. This is because 90 degree triangles we get to use the Pythagorean theorem for, and this is just a nice way of starting into trig because we get to use all of our different trig rules like sine, cosine, and tangent. Eventually, they get used with 90 degree triangles. So these ones in particular, they're very, very common ones that you might see in a lot of different problems, and they just come up quite a bit. They're nice and they're easy to remember. So here's how we're going to remember them. For a 45, 45, 90 triangle, it's going to be an isosceles triangle because we have the same angles in here. So this is 45, 45, 90. And because it's an isosceles triangle, if these angles are the same, remember I told you that the angles kind of tell us a little bit about the other side, the side that's opposite them. So if they're the same, then the opposite sides to each one are also going to be the same. So these sides here are congruent. This is an isosceles triangle. And the neat thing about this 45, 45, 90 triangle is no matter what those sides are, they always form the same ratios. And that ratio is going to look something like this. Whatever this leg is, we'll call it x. If that leg is x, then the other one obviously has to be x as well, because they're congruent. And then the hypotenuse is guaranteed, it's got to be x times the square root of 2. And you could verify that with the Pythagorean theorem as well if you'd like. Leg squared plus leg squared equals hypotenuse squared. That's a squared plus b squared equals c squared. So we get 2x squared equals c squared. Take the square root of both sides. X squared comes out of the square root, and we're left with x times the square root of 2 being equal to the hypotenuse c for verification. So this triangle, 45, 45, 90, with the sides x, x, and x times the square root of 2, is a very, very unique one. It's one we see a lot, and the problems that we might see for that could look something like this. Let me get rid of this 30, 60, 90 for now. Let's say that I gave you this triangle. Eight. And I wanted to know, well, what are all the missing pieces to this triangle? Can we fill in what is this side, what is this side, and what is this angle? These are my missing pieces. How can we possibly figure those out? Well, one of the pieces that we already know how to figure out is this angle down here, because every triangle has to add up to 180 degrees. And you might start to realize that, hey, I've got a 90 and a 45, and if you start memorizing these triangles, then you know that, well, the other bit has to be 45. 45, 45, 90. So here we've got 45 degrees. And now, for these other two spots, my other leg, since this is a 45, 45, 90 triangle, we kind of want to think back to the one that I'd like you guys to have memorized. 45, 45, 90. That base structure of it, the x, x, x root 2, x, x, x root 2. In this case, the 8 is on a leg, which we called x. Well, then this one here, this other leg, must also be the same thing. So it's got to also be an 8. Since the two legs are going to be congruent, these two legs must also be congruent. It's a similar triangle. We've done similar triangles before. And then last but not least, the hypotenuse up here. If we follow the same similar triangle, the hypotenuse should be whatever x is times the square root of 2. Well, in this example, x was 8. So the hypotenuse of this triangle is just going to be 8 times the square root of 2. And this leads to you being able to do a lot of these problems quite quickly. So for example, we could have Excuse me. We could have an example just with a different number, basically. Let's go like this. Let's say this is 45 degrees, 45 degrees. That means this is 90 degrees. And let's just go ahead and say this is 5. Well, then what's the hypotenuse of this triangle? Since it's 45, 45, 90, the hypotenuse will just be one of the legs times square root of 2. Just like we see over here, a leg times square root of 2, x times square root of 2. So this hypotenuse will end up being 5 times the square root of 2. And you can very, very quickly figure out the missing sides on these 45, 45, 90 triangles. Where it gets a little bit dicey, that I've seen students struggle with, is when the side that's given to you isn't one of the legs. So let's say that I give you the hypotenuse instead. Let's take a look at this quick example. Here we've got 45, 45, and 90. And this time I'm going to give you 9 right here. And I'm going to say, well, what's the leg? How long is the leg of this triangle? Well, you got to think back again. Our base triangle for 45, 45, 90 had x, x, and x times root 2. Just match things up a little bit. My hypotenuse here is 9. My hypotenuse of the triangle that I know the ratios of is x times the square root of 2. So let's say that the 9 is equal to the x times the square root of 2. Can you solve this for x? Absolutely. Instead of multiplying by root 2, we divide. So divide both sides by root 2, and we get 9 over the square root of 2 is equal to x. Now in math, we don't like to have square roots in the denominator, so we can multiply this by square root of 2 over square root of 2 to get rid of that, which will leave me with 9 times the square root of 2 over 2. Because the square root of 2 times 2, or the square root of 2 times the square root of 2, rather, gives me 2, but I also had to multiply the top. So x was 9 times the square root of 2 over 2. Now I know what these legs are, because the legs, according to my ratio, they're just x. So this is 9 times the square root of 2 over 2. 9 times the square root of 2 over 2. So that is it for our 45, 45, 90 triangles. I hope these couple examples here have helped you out. Tomorrow you're going to see a worksheet come up with 45, 45, 90 triangles. And the next day, on Wednesday, we're going to cover 30, 60, 90 triangles. Spoiler alert, you do them pretty much the same way. They're just a little bit more difficult because these legs aren't the same. We'll see you then.